Okay, hi. Whether you were in class or not today, we did sort of a project of sorts, talking a little bit about how to simplify expressions and some of the things to be looking for. But this is the actual sheet that we worked through with that. So I'm going to work through this a bit and hope that that helps you out a little bit. Simplifying expressions, kind of trying to find things that are alike that we can work with to make sure that we're combining the like terms. Especially, this is important when we start doing some more things with equations. For instance, here in our first problem, both of our terms have an x. So we can go ahead and just add their coefficients. The 4 and the 7 gives us 11x. Not x squared, we're not multiplying. Just leave the variable part alone, add or subtract the constant terms. Same here in our next one, except now it's 9 minus 12. Well, 9 minus 12, if I had $9 and I borrowed 12 to my friend, now I'm $3 in the hole, but I still have the y. Okay? And as we start to build on these, we'll get to a point where we have to start watching for different variables. But be careful. We always have to be sure that we watch the signs. Like this is a negative or a minus 1x. I can't just, the word combined doesn't necessarily mean we're going to go up in value every time. So if I have 3x's and I take one away, now I only have 2. If I have 7y's and I take 4 away, because the number that's in front of my coefficient makes me, whether I have add or subtract. 7 minus 4 is going to be 3. And that's as far as I can go because x and y are different bases. So you're like, okay, I'm starting to see what you're talking about here. And when you're doing these, it doesn't really matter. When we get into exponents, we'll pay a little more attention, but for now, if I say I'm going to start with the r's, 8 minus 7 is 1r. I can put 1r, I can just put r. Q's, I have negative 3. Plus 1 would be negative 2. Plus 5 would be a positive 3. Those are the type things we're looking for. If we come down to 6, we'll bounce around a little bit here. So I got negative 7k and a positive 6k is a negative 1k. So as we continue to take a look here, 8m minus 6 gets me 2. And negative 2 plus 2 is 0. Now I can put a plus 0 or I can just leave it this way. Okay, work that out, be done. Let me scooch down a little further here. I'm going to come down to 8. Because here's where we have to start watching things. It's very tempting here to do 2 minus 3 first, but I can't. This minus 3 or this negative 3 is attached to this quantity, this set of parentheses. So we have to distribute first. So we leave the k and the 2 alone. Negative 3 times 6 is negative 18k. And negative 3 times negative 5 is a positive 15. So whenever you can distribute first, you really do need to do that. Okay, we'll make a little note here. Distribute first. Once I've done that, now I can go back and find the things that are the same. And for a lot of you, I think putting a 1 in front of your variable term, if there's a singular variable, will come in handy, because sometimes we forget about it otherwise. We look at k minus 18k, we're like, oh, it's just negative 18k, but in this case, it'd be negative 17k. And 2 plus 15 is 17, and I'm done. So again, it's just something to be cautious of. Okay, number 9, same thing. We've got to do all the distributing first. When you distribute, it's to every term in the parentheses. So 8 times 3 is 24x. 8 times 4 is 32. 5 times 7 would be 35x. 5 times negative 8, and you're like, God, this takes a while. You're right, we're going to test your patience and your attention to detail here, but like I've said before, it's better to do it slow and get it right the first time than to go in a hurry and have to go back and do it again. So we'll kind of get things moved up here. Again, look for the parts that are alike. 24 plus 35 is 59, plus 2 is 61, and 32 minus 40. I had 32 bucks, but I went and spent 40. I'm $8 in the hole. Think money. Money makes everything easier to think about. Okay, so again, nothing too terribly complex so far. A little different, but we'll see. Let's move down to 11. Number 11. Now we start seeing exponents that are different for the first time. And here's what we're going to do with these. Whenever we see these, we're going to put them in order by degree, which means we go from the largest exponent to the smallest. So we go looking around, we say, okay, where's the largest exponent I see? Well, I see x to the third, and there's only one of them. So we'll do that first. Then I go, what's next? Well, x squared. So I have a positive 6 and a negative 3. So 6 minus 3 is 3. And I have a 5x and a 9x is 14x. And this, again, would be a polynomial of degree 3, which just means the largest exponent is 3, and we count down 3, 2, 1. We always want to write it that way because that's how it's going to show up in books and on standardized testing. So let's see here. Let's take a look at another one of these. Let's go to the uber hard one here, down with the star. Just like before, we're going to do all of our distributing first, even with that negative 1 that's sitting there. So again, even though I want to, I can't combine these first. All the distributing always happens first. So 4 times 7 is 28x. Now 4 times negative 3 is negative 12. Here's the first time we've run into this. X times x is x squared. Here's our first opportunity where the exponent starts to change. And that's only when we have multiple x's that we're multiplying together. Same thing in this first one in the next part. 3 times 2 is 6. X times x is x squared. 3x times 4 is 12x. And the negative 1 here, the negative just distributes and changes the sign on each of these. So negative 4 and negative times negative is positive 2x. And again, we're like, whew, that's a whole lot going on. That's why it's double star. This is a challenge problem. Now, where do I want to start this time? Well, if we think like we did before, we're going to order by degree. We're going to start with the biggest exponent. So negative 12x plus 6x would be negative 6x squared. Excuse me, I didn't mention the squares in the last part. Then I have a negative 1x plus 12x would be 11x. Plus 2 more gives me 13. And finally, oh, what'd I do? Harty, you missed an x. I did right there. See, this is why you got to be careful. I wasn't careful there. Negative 1 plus 28 is 27. Plus 12 is 39. Plus 2 is 41x. You can even go to C. I even make mistakes sometimes. I got to be a little more careful here. So here now we've got negative 4 plus 5. I owed my friend $4. I found a 5 in my pocket. I'm $1 ahead. Got this. Okay. Last one with the challenge problems. Find the perimeter of a rectangle. Whenever they give me something I can draw, I like to draw it. A length of 2y minus 4 and a width of x plus 3. Now what do I know, besides the fact that I need my rectangle to actually show up, what do we know about rectangles? What do we know about their sides? The opposite sides are the same. So we've got that. And then what's perimeter of something going to be? That's going to be when we add up all the sides. So I'm going to add all this stuff up, which basically means I'm combining like terms. So I've got 2y, I've got 4 y's. Okay, I can kind of check those off. I have 2 x's. Check those off. And I've got negative 4 plus 3. So owed my friend 4, gave him back 3. Now I only have 1. Found $3 in my pocket. Now I'm 2 ahead. Ooh, but then I went and spent 4. Now I'm down 2. And that's my perimeter. Okay. So there's some applications to this. There will be a head in geometry class. There will even be some in here. But the ability to be able to distribute and combine like terms is integral in being able to make sure that you can solve equations. So if you've gotten through this one, it's going pretty well. Great, you're ready for the other side with the actual homework. If not, be sure to ask some questions when we get back together.